All right, good morning, everybody. I hope you guys all had a nice day yesterday. I hope you can all hear me right now. If not, just flag me down, let me know there's an issue. Okay, so we have a lot to do today. A couple of housekeeping items to go over, and then a couple of problems to do, and then we have some notes to finish from yesterday before we start the notes from today. So first order of business housekeeping wise is the following. So we're still missing. Okay, we're gonna continue. Okay, so the first housekeeping item on the list is the Google Classroom. So if you open your Google Classroom, this is what you see, except for the save post, that's just for me. But you have all of these things, and it was brought to my attention that it's a little bit difficult to sift through if you're missing something, if you want to go back and find some notes, or you want to go back and find some solutions. So if you click the About tab, I've added the stuff here, okay? So the YouTube link is pinned right there. So that'll take you straight to the YouTube to watch the videos. There's a folder for class notes. So if you click on this folder, should be shared, open it up, and all the different class notes are in there. You've also got the handouts that you click on. So these folders should be shared with you. And handout solutions, so those are to the handout specifically. And finally, the assignment solution. So once you've gotten feedback for an assignment, those assignment solutions will be posted here. Okay, so basically this is just a way to organize it a bit better. So if you're missing something, you can go back and get it here rather than have to search through the classroom. Things will still be posted in the classroom as a stream on the link. That's where it'll get updated first. For instance, at 1 o'clock this afternoon, the notes for tomorrow are going to be posted. Sometime this evening or tomorrow morning, I will upload them to the drive. So that will be a bit of a delay, but they will first be posted in the stream. So keep looking for the stream for the new information. But if you're looking for older things that you couldn't find because there are a million posts here, because we use Google Classroom as our main source of communication, if you are having trouble finding anything old will be found in, oh, great. Yeah, you're right. I didn't screen share before I did that whole explanation. You know, it's all good. All right, let's do this again. Okay. Classroom, stream, in the about. It's a lot of stuff there. So in the stream, that's where we go. So if you go into the about, you have all these folders here now, okay? So like I said, you have the YouTube link. If you click on the class notes, it'll take you to a folder with all the class notes. If you click on assignment solutions, it'll take you to a folder with all the assignment solutions. That's for the forms and for the docs. Similarly with the handouts and the handout solutions. So like I said, those won't be updated at the exact same time that the stream is updated. So for new information, keep checking out your stream. But in terms of older stuff, if you want to go back and you can't find a document or you just want to see something quickly and didn't want to try to sift through the stream, everything can be found there now. Okay. So that was housekeeping item number 1. Housekeeping item number 2, remember tomorrow that we're in class 8:30 sharp. Bring the notes printed out, and I'm going to print out the handout for you. So you can take it or you can just use the copy online that you'll be provided with after class. But other than that, bring all of your questions. We have some time tomorrow to go over some stuff that you've been having difficulty with up until now, or up until tomorrow morning, I guess. So make sure to bring all of your questions. We only have one class theoretically left together in class because the next Wednesday that we see each other, it's your situational problem exam. So if you're having any issues, you want any clarification, tomorrow is the time. We do have some new material tomorrow as well, but I'll use the first part of class to go over some stuff if you're having difficulty with it. If not, I'm going straight into new material as per usual. Just we'll see each other instead of not seeing each other. So everything stays the same. Just bring your questions because I will take the time to go over them tomorrow. Okay, end of housekeeping items. Let's get started. So, no, this one and this one. Nope. This one and this one. Okay, so yesterday we left off here. Sometimes you have to open it twice or it misses important stuff. Yesterday we left off here and I said this is the problem that we would be starting with today, so to try to take a look at it. So I did give you the steps that you should be completing here for this this problem. It would be about your pages are a little different than mine are, so it'd be between page 24 and 26. So it's just after the notes we had just talked about distance point to line. Then we did a couple of problems distance point to line, and now we're at the second page of problems for distance point to line. Okay. So I left you the steps to do to complete this problem. So step 1 was rule of line AD. So step 1, when we're finding the rule, y equals ax plus b, you need to find the slope, y2 minus y1 over x2 minus x1. In this case, we have 30 minus 10 divided by 90 minus 10. Continuing along, that gives me 20 over 80, which reduces to 1 over 4. Now I know the rule of my line is y equals 1 over 4x plus b. We'll take a point. I'm going to use the 10 and 10. So I have 10 equals, here we get 10 divided by 4 plus b. This moves over. So that gives me 3 over 4. So the rule of my line here is y equals 1 over 4x plus 3 over 4. No, I made a mistake there. That's not 3 over 4. 10 minus 10 over 4. That didn't seem right. Okay, so this is, my apologies, 15 over 2. So we need this in general form though, so we can't use it the way it is. So if we remember, general form has to have no denominators. So the first thing I do here is I multiply by whatever's going to get rid of my denominators. So in this case, I'm going to choose 4. So the 4 distributes to each of the terms. So 4y. This 4 cancels out here, so that just leaves me with x. 4 times 50 is 60, divided by 2 is 30. I almost have general form, so I'm going to move this over. That gives me general form. That was step 1. Step 2 was find the distance point to line using b. So I have my distance is ax plus by plus c with those little funky brackets there, and a squared plus b squared. So I have a, what is my point? My point is 40, 60. So I have a is 1, and the x is 40. B is -4. And we have 60. And C is 30. All divided by the root of 1 squared plus -4 squared. Working this out on the top, I get 40 minus 240 plus 30 divided by the root of 1 squared. Well, 1 squared is just 1, so we're just going to take care of that right now. 1 plus 16. I see your question. I'll answer in a second, okay? So we get -170 divided by the root of 17. This becomes 170. The root of 17 is 4.12, and then I do my division, and I get 41.23. So there are 2 questions there. I'm going to answer them both at the side right now. So the numbers for the distance point to line, the A is the number here attached to the X. The B is the number here attached to the Y. The C is the number here, that's just the number. 40, 60 is my X and my Y. And then here the A and the B are the same on the bottom that the A and the B were here. So the A goes here as well, and the B goes here as well. So that's why we needed to find the rule of this in general form, and we're using this point. Why the distance point to line formula does not work? Sorry, the question is there a reason why regular distance formula wouldn't work? You could do regular distance formula, but to do what we just did, to find the shortest distance, because we want the 90-degree distance. To find the shortest distance, you would have to find the rule of this line, use the negative reciprocal to get the slope of this line because they meet at 90 degrees. Find the rule of this line, find the intersection point, and then find the distance with this point and the intersection point. So essentially, by just finding this rule in general form and applying this formula, you have 2 steps, versus doing it the other way, you'd have 1 step, 2 steps, 3 steps, 4, about 5 different steps to get to what we just did in 2. So if you're stuck, you can definitely do that, but it's a big, 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 big pain. You don't really want to be wasting time on your exam doing that. All right. The next thing we need to do is we need to get the distance from A to D. So this is where I apply the distance formula we're all used to using. So I have 90 and 10, and I have 30 and 10. Remembering that those are the coordinates of the 2 points. So here I have 80, and here I have 20. If I add those up, I get the root of 6,800, which is approximately 82.46. Now that we have both of those values, I know that the area of a parallelogram is base times height. So base being the 82.46 and the height being 41.23. So I just multiply them. And I get 3399.91 units squared. Any questions? Okay, before we continue with the notes from yesterday, the half planes, I just want to know if there are any questions people attempted to hand out yesterday. So if you have any questions from the handout yesterday, just post them on the chat and I'll take a look if we have time to go over some of them. The current question is, can we go over here? So basically, you have this formula, okay? So you have a line whose rule is ax plus by plus c equals 0. And you have a point, x and y. So that is why we need general form. So this is general form, okay? So this a goes here and here. So it's the number that's attached to the x. This b comes from this number here. This c comes from this number here. This h would be here. So in the thing, they're saying h and k. But that could be x and y. Okay? So basically, whatever this is going in there. And whatever this is coming from here. So you have the 3 numbers here that are popping into 1 or 2 different places. And then you have the coordinates of the point that are popping into these places. All of those things are numbers, so you should not have any variables. Anything else? No questions from the handout yet? Okay. So we'll continue. We're going to talk about half planes and graphing inequalities. So the blue part is something that you have to copy down. Can I scroll down? Okay. If you're not quite done, you can catch up when we're talking about them. So graphing inequalities. So you looked at a lot of one variable inequalities in secondary 3. Today, what we're going to be looking at is 2 variable inequalities, okay? So something like this. I'll be scrolling back down, yes. So basically what we have here is we have a lot of different pairs of numbers that would satisfy the inequality. For instance, here we could have 10 and 20. I could have 50 and -6. I could do this all day because there are going to be a lot of different pairs that will satisfy this inequality. Basically, what this is in general is this, if we look at this without the inequality, just quickly here, if we look at this without the inequality and put an equal sign, this is a line. So when you have the inequality, what you are actually doing is you have a line, but the line is separating the entire Cartesian plane into good solutions and not solutions. So solution, no solution. So basically half of the entire Cartesian plane is going to work and the other half is not. So the line itself, when we take this away, this line that we can graph is going to tell us how to separate the Cartesian plane, and then it's up to us to see which half of the Cartesian plane will give us good solutions. So the set of solutions exists either above the line or below the line. So to find, so there are 2 different types of problems that you can get with this type of thing. You could either get, here's a rule, which one of these graphs satisfies, is actually true, like actually represents what you have, or here's a graph, find the rule. So we're going to do a couple of examples of both. Now, we don't have an equal sign. We actually have an inequality, like I said, so we'd have something like this. So the inequality plays 2 important roles. It's going to tell us where the points are that satisfy our inequality, either above or below the line. It also tells us whether or not the points on the line itself are part of our solutions. So if I have greater than or equal to or less than or equal to, the equal to part of this is the important part. Because if it's equal to, that means I can include the points on my line. And when we graph it, we just graph it as per normal, as a solid line. If I have strictly greater than or strictly less than, we cannot include the points of the line. We graph as per normal, but instead of representing it by a solid line, we represent it by a dotted line. So we'll take a quick look at what this looks like. So if I have x plus y is greater than 10, notice how here it's just a greater than, there's no equal to. So when it's represented, the line itself that's separating our plane is represented by a dotted line. And notice how half of it is shaded. So half of it being shaded means all the points that are in this shaded region will give us good solutions. For example, if I have 0 and 20, 0 plus 20 is greater than 10. But if I have 0, 0, 0 plus 0 is not greater than 10. So these portions do not satisfy the inequality, do not give me a true inequality. Whoops. But any point in this portion does. So that's what an inequality looks like in two variables, a region of the Cartesian plane. So we could do this all day. If I have greater than or equal to, though, notice how nothing changed in terms of the region. The only thing that changed was the line. So it went from a dotted line to a solid line. That means that I can include these points. Is 0, so I'll take this point for instance, 0, 10. Is 0 plus 10 greater than or equal to 10? Yes. So the points on the line can be included as a solution. Okay, so this could look different. This could be 3x minus 5y plus is greater than or less than or equal to 12. Y. So notice here we have still two different regions of the plane. We have less than or equal to, so we have the solid line. If I take away the equal to, doesn't change my region, just turns the line from solid to dotted. But we still have all of these shaded points that give us a true inequality. Good grief. So like I said, we're going to be doing two different things. Potentially, we're going to be creating the region ourselves, or given the region, we're going to create the inequality. So I'll give you a second just to write down these two quick things. Okay, so if you're given, so this is for finding the region if you're given the inequality. So the following steps are what you're going to do every time. You're going to graph the line as per usual. Any tool you have to graph your line, use it. Find 2 points, sketch the line through. That's all you need. You can be given the lines in, what's it called, symmetric form or general form or functional form. So you just have to be able to graph. But when you're graphing, just graph the line and then make the line solid or dotted depending on the inequality sign. You're then going to choose a test point because we've just divided the Cartesian plane into two different regions. We need to know which region is good. So we're going to test a point. Choose 0, 0. Like that's the easiest one to use. You could choose whatever point you want, but for simplicity's sake, I'm going to choose 0, 0 unless the line passes through 0, 0. Then you cannot use it. If your test point gives you a true inequality, that's where you shade. If your test point gives you a false inequality, you shade the other half. So it's actually simpler than it sounds. So let's test this out. Cool. All right, here you have this rule. Here you have your Cartesian plane. So what you're going to do is you're going to find 2 points and you're going to graph it. So this is my first point, 0 and 1. And then I have a slope of 1. So I've got up 1 over 1, up 1 over 1. Whatever tool you need to graph your line. Now, when I graph my line, before I sketch, I take a look at this. It's not equal to, so when I draw my line, I'm going to do it dotted. Not like a line here. Dotted, please. Okay, fine. So your line would be dotted. So this separates the region into above and below. So now you're going to take a test point to see which one of these work. So because it doesn't pass through 0, 0, it's easier if you test 0, 0. So you plug it in. You say, is 0 greater than 0 plus 1? Is 0 greater than 1? No. What this means is 0, 0, this is false. So I do not want 0, 0 in my solution set. So I shade the other half. 0 is below, I'm going above. There's my region. So any point within the shaded region gives me a true inequality when I test it. Two. 2x plus 3y is less than 12. You need to graph this. I need 2 points. So I'm just going to say, let's find the x-intercept and the y-intercept. Do whatever you got to do. Figure out how to graph it. Doesn't matter how, just graph it. So for the x-intercept, 2x. I hide this if we remember because the y becomes 0. So x is 6, meaning that this is the x-intercept. 3y equals 12 to get the y-intercept because this disappears. So y is 4. So I have 2 points. And now I'm going to sketch the line through them. This separates into 2 regions. It doesn't pass through 0, 0, so I'm going to test 0, 0. You can test whatever you want. The same thing applies, but 0, 0 makes my life easy, so I'm going to do it that way. 2 times 0 plus 3 times 0, is this less than 12? Well, this is 0, this is 0. 12? Is 0 less than 12? Absolutely. So wherever 0, 0 is, I'm going to shade that side. There you go. Done. We'll do this one quickly. Graph the line however you can. So I'm going to get the intercepts. I'm not. I'm going to move this to functional form because I can, and I don't want to find the intercepts. Divide both sides by 5. That gives me 2x plus 5 equals y. So that's my new rule. I start this at 5. And my slope is 2, so I go up 2 over 1. 1, 2, 1. Oops, little dot there I don't need. Up 2 over 1, up 2 over 1. Get a couple of different points there. Sketch it out. Again, we're dotted because our inequality is less than strictly. It does not pass through 0, 0. So once it's graphed, I'm testing. Now, do not always go back and test your original equation. Don't do what you manipulated. So this is kind of like a side note that just helps us graph, but it has nothing to do with my work. So when I test 0, 0, I'm testing it in the original. So I get 10 times 0. Is this less than, question mark, 5 times 0 minus 25? Is 0 less than 0 minus 25? Is 0 less than negative 25? No, this is false. So 0, 0, not part of my solution. So I shade the other side. And we're done. Good? All right. So we're going to do a couple of these working backwards. So just take a quick second to write down the blue and then we'll continue. So when you're given the picture, in order to create the equation, what you're going to do is you're going to create the equation of the line. You're going to test a point that falls within the shaded region. You're then going to insert the proper inequality, paying attention to solid or dotted line. So that's it. Rule, test point, insert inequality. Ready? Speak now. All righty. All right. I need the rule of this line. So this goes up by 2's. So I'm pretty sure we'll take a look at this. This is 5 and 5. It's going to be clear. But if you look, this is right in the middle. So this is 5 and 5. So this is where your tools for symmetric come into handy, because I can have x over a plus y over b equals 1. And if I have 5 and 5, I don't even have to do anything. This is a legitimate rule. Test 0, 0. That's symmetric, exactly. So that's actually one of the benefits of understanding symmetric, is being able to do this, because you just find the two intercepts and plug it right in. So because 0, 0 falls within my region, I'm going to use that as my test. So what you do is you plug it in. You say 0 over 5 plus 0 over 5. We're going to leave like a blank space for our inequality and 1. So this gives me 0 plus 0, my inequality, and 1, 0, 1. Well, is 0 bigger or is 1 bigger? Well, 1 is bigger. Now the question is, do I have greater than or equal to, or less than or equal to, or just less than? Well, my line is solid, so there we go. I include that. So I have x over 5 plus y over 5 is less than or equal to 1. Question is, do you have to do the testing, or if you know by looking at it, that's okay. If you have some way of knowing, fine. Just be careful. I recommend testing just because that way it gives you like a real concrete way of doing it, but it's up to you. Here we go. All right, I got an intercept here of 4. I'm going to use symmetric. Unless your intercepts aren't nice, you can use symmetric and it's perfectly acceptable and it makes your life easy. Like, look how easy this is. I have 2, 4, x over, well, that's y, duh. Y over 4 and x over -2. I don't have to do the slope and the intercept and all that. I'm going to say nonsense. It's not nonsense, but this is more straightforward. So 0, 0 does not fall in my solution, but I am going to choose something that has a 0, because if one of them 0, still makes it easier for me. So 0, 10, you can choose whatever you want. 0, 10 is in my solution set. So I'm typing in, whew, no one's typing anything. 0 over -2 plus 10 over 4 is something to 1. So 0 plus, this is 2.5, something to 1. 2.5, 1. 2.5 is bigger. It's dotted, so it's just bigger. X over a. X over -2 plus y over 4 is greater than 1. Is this clear for everybody? Do we need to see one more, or is this enough for us? One more. Cool. All right. This is not really perfect. We have our suspicions, but I'm just going to give you another tool in case it isn't perfect. This is, though. It's not really going to be. 2, 4, 6, 7. That's okay. X over a plus y over b is 1. I'll tell you right now, this will be very, very clear. If you get this question in the exam, there won't be any questioning. Is it? Is it not? It's very clear. X over -7 plus y over 8 is 1. 0, 0 falls within my point, so I'm going to test 0, 0. 0 over -7 plus 0 over 8 is equal to, we're not saying it's equal to anymore, something to 1. Here we get 0 and 0. So we look at the something, we say this something is less than, it's dotted, so it stays less than, So we get x over -7 plus y over 8 is less than 1. So just one quick note. Notice when I'm testing, I don't change sides. And nothing changes sides. Everything stays, if it's on the left, it stays on the left. If it's on the right, it stays on the right. Same thing when I did these problems. When I tested, nothing changed sides. I stayed on the right if it was on the right. It stayed on the left if it was on the left. I didn't move things over, nothing. When you're testing, you have to make sure everything stays where it is. You're just testing the point, plugging it in, and doing the left side with the left side and the right side with the right side. All right, these are type of examples that you could get. We're going to do the first two. These are type of questions that you could get in the final. So we're just going to cover them to make sure we kind of understand how to approach this. So this is a question that you can get as a part A. So you're given this graph and you have to identify which one it is. So what you're doing here is you're doing a process of elimination. So there are different things that you're looking for to help you eliminate as many of the graphs as possible. So the first thing you look for is the dotted solid thing, because sometimes you'll be able to eliminate 2 of the cases just based on that. So I look, this should be dotted, but they're all dotted. It doesn't help me. That's fine. I need to find the intercepts because clearly that's how they're graphing this. So either it's the y is 25 and the x is -15, or the y is -15 and the x is 25. So x intercept, y 0. This is general, so I'm just going to solve. I'm going to pretend this doesn't exist, okay? I'm just going to solve. So 5x plus 75 equals 0. 5x is -75 by bringing it over. So x is -15. So I've just eliminated this case and I've eliminated this case. In both of these, x is -15 and the y is 25. So I'm not even going to bother finding the y because it's irrelevant. It's the same for both pictures. What I'm going to do now is I'm going to test 0, 0 and see if it works or if it doesn't. So test 0, 0. So 0 times 5 minus 3 times 0 plus 75 and 0. Is this, we'll put the sign in, so we actually know the sign. We'll put a question mark over because that's what we're seeing. So 0 minus 0 plus 75. This gives me 75 is greater than 0. So this works, which means that I want this option because 0, 0 should be in my shaded region. So you're checking to see which one's graphed properly, which one is dotted solid. Everything in the shaded area works, everything. Test another point if you want, and they will all work. You could do it all day. Not the way I would choose to spend my day, but if you want to, that's cool. So if you get a question like this, like I said, check to see if they're graphed properly, check to see, so like the intercept or whatever you're given, check the dotted versus solid, and then check the shaded region. And you're done. 4 points. Lovely. The other type of question that you could get is this one. So you could get this in a part B. The half plane below is represented in the Cartesian plane below. The half plane represents the solution set for which one of the following inequalities, or just create the inequality. So here I actually have to find, so if you get this in a part B, you have to find the rule. Now it doesn't matter which form you find the rule in. In this case, I'm gonna do the y equals ax plus b because I don't have the two intercepts, but I do have one of them. So here I have negative 20 minus 20, over 80 minus 0. So that gives me negative 40 over 80, which gives me negative 1/2. I have y equals negative 1/2 x. This is my y-intercept plus 20. Then I test 0, 0 because 0, 0 is good for me. So here I have 0, 0. This goes away. I have 20. I want this to be greater than and equal to. So y, or the 20 needs to be greater than or equal to. So then I put this in the same way. Now, if you get this in, you could get this type of question in a part A as well, and they would just give you 4 different types of rules. But the thing is, they may give you symmetric, they may give you general, they may give you whatever. So you have to, before you do the testing in that case, you would have to switch this to whatever form you want or whatever form they need and then test your point, okay? Y equal to, because it's solid line. It's a solid line here. Half plane, the thing half plane, this is a Cartesian plane, so the whole thing is a plane. Half plane means this line divides it into half. So in this case, it's the bottom half, but it could be the top half. But this line divides the whole Cartesian plane from negative infinity, positive infinity into half. So it's a half plane. So all the different points in one half are going to satisfy my inequality, and all the points in the other half are not going to. So that's why it's a half plane. How do we feel about this? Okay, cool. All right, so we are ready to move on to today's notes. So there are a lot of things that we can do it very, very quickly, then we gotta move. Okay, here I have nice intercepts. X over A plus Y over B is equal to 1. This is negative 12. This is 2, 4. Negative 4. Testing 0, 0. Zero over negative 12 plus 0 over negative 12. And we have 1, 0, 1. So we want this to work, so we have it this way. Yeah, 0 divided by negative 4. Here. Irrelevant, but yes. So we want it this way. Thank you for the correction. We want it that way. So I'm just going to change this here to this, and I'm done with it. Negative 12 is the x-intercept here. -4 is the y-intercept. Cool? Awesome. All right, today's notes. So today's notes, we're supposed to be going over quadratic and doing something new. So there are a lot of pages that I'm going to just have you copy down the notes because it's old material. So the properties of functions, these are old, this is old material things. It's just a quick refresher. So we're not going to do much with it. So this is on page 1. So we're not going to do much with this. I'm just going to have you copy the notes and we're going to blitz through until we get to the new material. Okay. Actually, you know what? Even better yet, here's what I'm going to do. Because we're running out of time and I find we really have to cover this material today. What we're going to do is I'm going to post the, not solutions. I'm going to post this lecture filled in. So with all the blue. We'll just, so don't worry about writing it for now. We'll just take a quick look at it together. So that should take us about 5-10 minutes. So don't worry about writing. Just heads up and listen and we'll get to the end, okay? Makes our lives a little easier for today. So just as a review and refresher, we're gonna go over properties of functions and we're gonna quickly go over quadratic. And then we have one little thing to talk about today. So domain is set of all possible x values that the function can take. The range is the set of all possible y values the function can take. The y-intercept, which we call the initial value. You use this a lot with lines, so we're pretty much used to that terminology. We have the value where the graph crosses the y-axis. General notes, if the graph is a function, so we remember the function, we test this by the vertical line test. If the graph is a function, there can only be one y-intercept. If we have a rule using algebra, we set x equals 0 and solve for y. So that's what we were doing before with the intercepts in general form as well. We have the x-intercept, also known as the 0. So those two terms are interchangeable. So you'll sometimes hear zeros, you'll sometimes hear x-intercept. The value or values where the graph crosses the x-axis. So there can be multiple zeros, even if this is a function. To solve algebraically, you set y as 0 and solve for the values of x. So again, we were doing this a lot when it came to lines. Extrema, the max or the min, max or min. And we have the absolute extrema, the absolute maximum, so the absolute biggest y value that we see or that will happen. Or the absolute minimum, which would be the smallest y value or the lowest y value that we get. Then we have variation, which is where the function is either increasing, decreasing, or constant. Constant means there is no change in the y-coordinate for a given interval. So basically a horizontal portion. Increasing is, as we move from left to right, there's an increase in the y values. Decreasing, as we move from left to right, there is a decrease in the y values. General notes, The constant portion can be considered both increasing and decreasing and gets included in both. Strictly increasing or strictly decreasing does not include the constant sections. And when we're reporting our solution, we're always reporting where it happens, meaning the x coordinate of the change and not what the y value is. The last one is sine. So sine tells us where it's above the x-axis and where it's below the x-axis. And inverse we're going to talk about today. So putting it all together, we have the different properties. We have domain, that's an x value. 0, y-intercept, that's x-intercept, that's an x value. Variation in sign that you're reporting back to x values. Range, y-intercept, and extrema that are all y values. So when you perform a study, you're defining all the different properties. Okay, so you have a couple of examples of that in your handout. We now have the basic quadratic function. So this part should be reviewed. So I'm just going to talk about a couple of things quick, just to make sure we all know. So we have the basic one, y equals x squared. We have the transform function, which is really what you use. No one really uses the other one because it's too, like, it's basic, right? So we want to do the transformed. So the transform function is y equals ax squared, where a affects the positioning of the parabola. Positive a means that the parabola opens upwards. Negative a means that the parabola opens downwards. It affects the general shape of the parabola. So the bigger the number, the skinnier the parabola. And if it's between 0 and 1, it makes it wider. Okay. So for instance, we have different types of pictures. So all of these have positive a. All of these have negative a. And the value of a will determine how wide the parabola gets. If you're graphing, make a table of values, plot your points, and sketch the curve. That's all you got to do. When you're finding the rule, it's very straightforward. You write down the rule. When you're doing this with lines you need a minimum of 2 points to be able to find the rule. For a quadratic of this form, you only need 1. So you plug in a point other than 0, 0. I'm going really fast because this stuff you already covered this year. So if there's a specific thing that you'd want to go over, let me know, but this is review. But I'll try to slow down a bit. So for quadratic, remember we have this. When we're writing down the rule, you plug in a point other than 0, 0, solve for parameter A, and then use the rule to solve for any further questions. For example, we'll do a quick one here. Find the equation of the second degree function that passes through 6, 9. So we have y equals ax squared. We have 9 as my y, 6 as my x. 9 equals 6 squared is 36. Nine divided by 36 is 1/4. So my parabola has a rule of 1/4 x squared. Okay. Just quickly though, just a quick reminder. So here, given a second degree function, so that's a parabola that passes through the point -6, -12, find the following values. So this means x is 12, and this means y is -27. So let's do this one quickly. Y equals ax squared. I have -12 and -6 squared. -6 squared is 36, and I divide by 36 to give me -1/3. So my rule is y equals -1/3 x squared. So to solve for this value, I would plug in 12 here as the x. So I get -1/3 of 144, which gives me -48. So 12 and -48 is a point on my parabola. The trick with parabolas, if you remember, y equals -27. So if I'm solving for a y, the negatives cancel out. I have 27 times 3, which is 81. When I square root, I get x's -9 and 9, because -9 is a point on, because when I square root 81, I have the positive case and the negative case. So for each y value, I have 2 different points. So I have 2 different x values. Okay. A little bit better? All right, so with quadratic functions, you learned a whole bunch of different things during the year. You need to know the same things. So for quadratic functions, you need to be able to graph them, find the rule, find different points. That's pretty much it. So on the new handout, I didn't want class 5. Handouts and solutions. Someone had muted me. So guys, please be careful. I was able to unmute myself. It's okay. Can you hear me now? Cool. Okay, so I don't know how much you missed out on when I was muted, so I'm just gonna reiterate it quickly. The handout that you have for today has a lot of practice on quadratic functions. So a lot of questions to do with this. So it's just review, okay? It's just understanding here when to use quadratic, here when to use quadratic, how to find the rule forwards and backwards, what A really represents. So this is a lot of practice on quadratic, okay? This does come back up a lot. I threw a couple of periodic questions in there too, just to give you a little review of that. And on the notes, there's a little review of periodic and piecewise functions. So check that out. Are there any questions about, I know I did this really fast and I apologize for that, but I wanted to look at it quickly together, even though we didn't necessarily have to, because theoretically this is review and you should have already covered this in your classes. But I'll take the time now if there's any questions. I apologize for going very quickly. Any questions on that before we move on? Oh yeah, that's what we're doing next. That's new material. I just mean the quadratic function very specifically. So inverses is what we're about to talk about now, which is new. Theoretically. But anything quadratic. Okay, cool. All right. Again, no need to copy down. The inverse of a function basically means we take all of the different pairs and we switch the x and y value. So every single pair on the function, line, curve, whatever, I take every x and I switch it with the y. Each ordered pair switches, so 2, 7, we flip them over, becomes 7 and 2. What this means is every single point in the domain becomes the range. So all the x's become y's, and the range becomes the domain. All the y's become x's. So that's just what this means in a little bit more formal term. Graphically, what we are doing is we are reflecting over the line y equals x. So if you remember in elementary school, some elementary school did this, some didn't. You had that little red thing that you could see through to draw a reflection of an image. So it reflected the image on the other side and you could trace it. Some people have seen it, some people have not. That's fine. Depends on if your elementary school had it. But essentially, that's what we're doing with these, okay? So graphically speaking, you're taking, so I'm going to put this full screen again. You're taking this line and you're reflecting over it. So like I said, graphically speaking, if you're just drawing like a sketch here, you see this one would go here, and this one would stay the same, but this one would go here. So essentially, it's a mirror image. And then I would sketch the line through. So notice that red and blue are mirror images of each other. So this means that they're inverses. Now, like I said, find some points. So here I have 0, 5. What this means that I should have 5, 0, which I do. Here I have -7 and -6, meaning there should be a point, -6, -7, and there is. So this is my reflection line. So it just helps you visualize. So if you turn your screen, which is really not easy, but if you turn your screen so that this line is straight up in the air, these are the mirror images of each other, one side and the other. Okay, so when you're doing this graphically, you're just basically mirror imaging it over the line. But you're never going to do it graphically because that's a huge pain in the butt. But honestly, what you'll do is you'll just do these reflections where you take the points and you flip them over and you get your new picture. But I just wanted to go over what it looked like in a graphical sense. So even here, if we do number 2, in theory, like I said, you're reflecting over, thank you, this line. But you're not really going to do it like that. What I'm going to do is I'm going to take some points and I'm going to flip them. So here this point is -2 and 4. So I should have 4 and -2. This is 2 and 4, so I should have 4 and 2. 4 and 2. This is 3 and 9, so I should have 9 and 3. And same thing here, -3 and 9, 9. So these ones, 1, 2, 3. And then I can just draw the curve through. So blue and red are inverses of each other and black is the reflection line. So just quickly, we have the vertical line test to see if a picture is a function. So if we remember what the vertical line test is, I take a vertical line and I move it over my graph to see if at any given point I have 2 points on the same vertical, which I don't, so this is a function. But if I want to know if the inverse will be a function, I do the horizontal line test. So it's the same idea. I take a horizontal line and I see if I have any 2 points on the same horizontal. I have tons for this one. That means that the inverse, not a function, which is fine. If we apply this thinking again for this one, so I'm going to take my horizontal line and I'll move it here. I scan. And I never really have 2 points on the same horizontal. So the inverse is a function. So straightforward, chances are you're not going to be asked something like that, but I just want to cover it because it's a little subsection of inverses. Ish. So that graph came from this. So I know it looks like it, but it gets infinitely close, but it never actually touches it more than 1 point. So if I keep zooming in forever, you'll actually see that it doesn't actually touch. It just gets like infinitely closer. It's one of those things. Yes, that's what I said. That's why I went over them quickly. I'm going to be posting the notes, this complete note set. I'll just do it. I'll post it with the blue copy after class, so probably around 12:30. or 10:30, depends if I have time in between. Okay, algebraically speaking, there are two different ways you could do this. Either we're switching the x and y values if you just have coordinates. So for instance, if you just have these 3 little sets of coordinates, you take each of the points and you flip them. So point 1 would become 7, 5. Point 2 would become 12, 2. And here, this point would become -8, -4. But what happens if we have a rule is that what we are going to do is we're going to be switching the x and y value in the rule, and then we're going to isolate the y value. So if you have this rule, we switch x and y. That's what we were doing even with the points before. So we're switching x and y. So we say x equals 2y plus 7. But this is not a proper rule. Rules always have the y isolated. So I'm going to work to have the y isolated. So I'm going to move this over. Then I'm going to divide by 2. That gives me x over 2 minus 7 over 2 equals y. So this and my original function are inverses. So if I graph them, I'm going to zoom out here. There we go. And x divided by 2 minus 7 divided by 2 equals y. We see that, and we have this just as our reflection line. So this basically shows us how we're reflecting. But if you see, red and green are the mirror images of each other. So that's how we algebraically find the inverse. So we've got the different points that we could switch here. We'll do 2 more. So find the inverse of that function. So our first move is to switch the x and the y. So I say x goes where the y is. So I have y minus 4 divided by 2. And now I need to just quickly, the question was asked, why is it not just x minus 7 over 2? Because this divided by 2 is on both of these things. So to separate it, I need to put this over 2 and this over 2. Just like here, I could theoretically separate this into x over 2 minus 4 over 2. But both of them have to be over 2. Okay. Alrighty. So now we're working on isolating the y. So I'm going to put this 2 up. It multiplies. And then I'm going to move this 4 over. So this and this are inverses. We're going to do the same thing. It's still a rule. It's a little bit more complicated, but it's still a rule. So I have y equals 2x squared. To find the inverse, I switch them. Okay? Now I need to isolate the y. So the first thing I'm going to do is divide by 2. And then I'm going to square root. So this here becomes just a y, and this stays as the root of x divided by 2. So this and this are inverses of each other. Now the question is, what does this look like? So if we see what this looks like, we have, I'm going to just type it in like this, x equals 2y. This is what it actually looks like. Okay, so we just take the thing and we flip it. You're flipping it and rotating it. But this, like we know, is not a function. So if I pass the vertical line test here, this is not a function. But actually, we can manipulate this so that it is a function. So this brings us to what we're going to talk about. The inverse of a quadratic is not a function. So like we said, we have this picture here. We pass the vertical line test. It's not happening. It's not a function, period. It has so many different places where it's not following the vertical line test, where we have two points on the same vertical. Algebraically, we just did this. So if we switch the x and the y, we square root. We have square root of x equals y. So what we do is we consider only half of the inverted parabola. So let's take a look at what this looks like. So actually, y equals root. So the actual function, notice here we have the square root function. And see how we only consider half of the graph. Okay, so we only have half of this sideways parabola. So that's going to be our new function. The question on the side, when do you know when to use the horizontal line test or the vertical line test? So the vertical line test is when you're testing to see if what you have itself is a function. The horizontal line test is when you're testing for if the inverse of that picture will be a function. So we're working with the square root of x. This is our new function. We call this the square root function. It is the inverse of a parabola. So like I said, we had this other side, to make it a full parabola, but we're just erasing it so that we only deal with 1/2 at a time, because 1/2 is a function. So if we test it with the vertical line test, this is a function. Whereas if we had the whole parabola sideways, this would not be. So to keep it a function, we are just working with half of it. Okay. So we'll just do a couple of quick examples of algebraically, again, finding the inverse. So inverse, switching x and y. So x equals 5 negative y. Solving for y means dividing by 5. So I have x over 5 equals the square root of negative y.
I'm going to take this and square it, square the whole thing. So this gives me x squared over 25 equals negative y. The negative goes over, so I have negative x squared over 25 equals y. So these two functions are inverses of each other. We'll do one more. Why did I square it? Because that's the opposite. The opposite of square root is square. So we'll do one more. Here, I'm going to switch the x and the y. So I get x equals 1/4 y squared. First, I'm going to bring this up to give me 4x equals y squared. Square rooting gives me the square root of 4x, which is equal to y. But we know we can pull that 4 out. So the 4 comes out as a 2, and I'm left with the root of x equals y. And these two are inverses. The other question, sorry I didn't see it, was why negative? Because you had a negative here. So the negative just flips to the other side to give me a positive y with the negative x squared. Okay. So here, this is my inverted function. So now I understand that a square root function is the inverse of a square function, which is a quadratic or a parabola. But this is a function in itself. So what does this function look like? What are its properties? How do we use it? Great question. So we had this basic one. Where this is what it looked like. So we have the y equals the square root of x. So notice that it only starts here. There's nothing on this side, and then it just goes on forever. But just like we had the basic quadratic function, basic exponential function, we have the basic and the transformed. So the transformed function has two different parameters, a and it has b. So a number inside the root and a number outside the root. So basically, we'll look at what role each of the different parameters plays. So this is our base case. When I change the value of a, okay, when I make it bigger, notice here how it stretches it up. We'll go back to 1. What do you think is going to happen if I make it smaller? Well, after 1, it makes it smaller and smaller. What happens if it goes negative? Well, it flips over. So I get the other half of the quadratic that I didn't have before. So a plays 2 roles. It condenses or stretches it. And it keeps it either above the x-axis or below the x-axis. So let's go back to our base case of 1 for a. What role does b play? So we'll go bigger on the b. So b and a play the same kind of role when we're talking about stretching or condensing. Okay, so if I go below 1 but still positive, same thing, it's making it smaller. When I go into the negative case, so a flipped it over vertically, so it flipped it over to go on the bottom. When b is negative, it flips it over to go on to the left. So this gives me, if I go back to my base case, this gives me 4 different cases. If A and B are both positive, I've got it in this quadrant here. If A is negative, but B is positive, it gives me this quadrant here. If they're both negative, it goes into this quadrant here. And if A is positive, but B is negative, it goes into this quadrant here. This is a lot of information. We're going to write this down. So for blue case, I have A is positive and B is positive. For orange case, I have that A is negative, but B is positive. For purple case, it's above, so A is positive, but it's below, so B is negative. And for black case, they're both negative. This is going to become super important when we're solving for the rule. Okay, so we need to know these 4 cases. This picture is something you should be sketching onto your memory aid. So negative A flips the function over the x-axis. Negative B flips the function over the y-axis to give us these 4 cases. So our domain and range are really specific to which of the 4 cases I have. Because remember, domain and range are the possible x values and the possible y values. But this is really complicated to solve for with 2 parameters. So what we are going to be doing is we're going to reduce this case, 4 cases, to 2 different cases. So rather than having one y equals a root of bx and having to solve for 2 different parameters, we're going to reduce this. A is going to absorb b. And we have 2 different cases. Either we have an A with a negative B. So in this case, we'd have, so this would be for black and purple. And this one with the positive B would be for blue and orange. So when we're solving, this means that I reduce it to just 1 parameter that I have to solve. If I have 1 parameter, what this means is I need 1 point. But you need to decide which case you have in order to be able to use that 1 point. So in order to find the rule, oh, we're almost done, actually. I'm impressed. In order to find the rule, you're going to draw a sketch. Very, 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 very rough sketch. The sketch is only to help you decide about the sign of B. That's it. So either B is +1 or -1. So either you have the case of y equals a root of negative x or y equals a root of x. And that's going to, which one you decide on is going to come from your sketch. Then you plug in a point and solve for A. Find the rule of the square root function that passes through -410. So the first thing is, I really like, your sketch is so rough, really doesn't matter. So I just draw a quick Cartesian plane and I say, okay, -410 goes here, -410. Meaning that roughly my picture is going to look like this. But I know if it's on this side, that means B is negative. So I have this case that I'm working with. Once I've determined that case, I plug in the point. So 10 equals A. I have the negative, and I put the -4 in brackets. So -4 just gives me +4. The root of 4 gives me 2. And divide by 2 gives me 5. Meaning that this square root function has the rule y equals 5, the root of -x. Good question. So the question is, how do you know which way to sketch it? So basically you need 1 point. So they have to give you 1 point. So in the Cartesian plane, -4, 10 falls here in this quadrant. So I just have to pass, I know it's going to pass through 0, 0 and curve out. If we just do the sketch of this one, I have my Cartesian plane. Dun, 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 dun. This is going to pass through 16 and 2. So approximately, I say, well, this is going to be 16 and 2. So it's somewhere in here, meaning that it's going this way. So all you're doing is plugging your point in and drawing a sketch just to see the direction of it. So in this case, I would get y equals, this is a positive b. So I would have the case y equals, and the x would be positive under the root. So you would plug the point in. 2 equals a, the root of 16. The root of 16 is just 4, and I divide by 4, which gives me 1/2. So my rule is y equals 1/2 root of x. If you choose incorrectly, you're going to get an issue. So if I had chosen incorrectly, just quickly here before we run out of time, if I said, oh, this is just a root of x, when I plug this in, -4, here's my problem. I can't square root a negative number. So if you choose incorrectly, it's going to be very obvious very quickly. So choosing the right case takes care of this problem. Okay, so just quickly before we end, I am going to post these notes ASAP. I'm going to try to do it between the 2 classes here. Make sure you're checking the video. The handout's going to be released. The majority of it is quadratic function. So make sure you're checking that out. Okay, so it is quadratic function. Then we have some problems here. We're going to start with these problems tomorrow. Make sure you're checking out the handout from yesterday. Okay, the handout from yesterday has some questions on the Cartesian plane, the half planes. So make sure you check those out. There are even some problems, some part C problems, like here, for instance, number 50, that has a half plane in a part C. So make sure you look at that. The assignment from yesterday also has there's a question on the docs that has a half plane in the part C as a part C type question. So please check that out. So like I said, tomorrow we will continue with these notes, and then we'll pick up with the new material. Check out, please, please, please practice the problems. I went over assignment 5. Most of you hadn't done it. Try to keep up as much as possible with the assignments, okay? So if there are any other questions, feel free to email me at any point. Otherwise, I will see you tomorrow morning. Looking forward to seeing you all. Have a good afternoon.
Thank you.
Thank you.
What's more important, handout or assignments? Assignments, I'm going to give you feedback on. You should be doing as much of both as possible because the more practice you have, the easier the problems will become. All right. Have a great afternoon, everybody.